we stopped on the moment of general scenario for quality attributes. Now we'll take a look for concrete examples of quality attributes or architectural characteristics, non-functional requirements. The first one will be availability. What it is. So availability refers to the ability of the system to mask or repair faults such that the cumulative service outage period does not exceed a required value over a specified time interval. In other words, availability is about what is the time when the system is not available to operate, and how to make this unavailability as less as possible and to make availability as more as possible. So fundamentally, availability is about minimizing service outage time by mitigating faults. The availability of the system can be calculated as the probability that it will provide the specified service within required bounds over a specified time interval. So this is one of the quite well-known expression used to calculate steady state availability here. MTBF variable, it refers to the mean time between failures, and MTTR refers to the mean time to repair. In most cases, you can imagine that here you will have values like 0,99999, something like this one. So let me show you one of the examples. Here is the table of availability if we will calculate it to 90 days or 1 year. So let's imagine if the percentage of availability will be 99%, it means for 20 days it's 21 hours 36 minutes. For the year it means 1% if it will be not available at 3 days and 15 hours. As much as you are wishing to grow these characteristics, for example, even to 39 after the dot, it just 5 minutes per year, the system will be unavailable. As much the cost of this solution will grow in exponentially, and it's quite hard to achieve these high characteristics of availability. Maybe one of the famous and quite hard values of availability has, as you know, one of the main, the famous one, the Google. They have quite good availability, but so you are able to work with these resources almost during all year, but the cost, the price of this is quite high. Availability general scenario. Here is the general scenario for availability. So as a schema, as a plan, we have the next step. We have the source, stimulus, artifact, environment, response, and response measure. What kind of source can be for availability? It can be external or external: people, hardware, software, physical infrastructure, physical environment. For the stimulus, stimulus, what can be omission, crash, incorrect timing, incorrect response. Artifact, processor, communication channel, persistent storage processes. Environment, normal operation, startup, shutdown, repair mode, degradate operation, overloaded operation. Response, prevent the fault from becoming a failure, detect the fault, recover from the fault. And measure, so that's what we have to measure, this timing. So what will be the time to detect the fault, time to repair the fault, availability percentage, time or time interval in which the system can be in degraded mode. Based on this general scenario, we will be able to build concrete scenario. Here is the sample of concrete scenario. For example, it will sound like this one. The heartbeat monitor determines that the server is non-responsive during the normal operation. The system informs the operator and continues to operate with no downtime. Based on this information, how can we build our concrete availability scenario using the general one? For the source, based on this sentence, what will be the source? The source will be heartbeat. So heartbeat monitor what it is, what kind of stimulus it determine. It determine unresponsive, non-responsive during normal operation. So during normal operation environment, it was normal operation. And artifacts, what we are working on is a process. What kind of a response can be in this case? The system informs the operator to continue to operate with no downtime. So response, it will be inform operator to continue to operate. This is a response to this stimulus, that the heartbeat detect that process is unresponsive, and the response will be for this action to inform operator. How can we measure it? We can say that this measure for this response, inform operator continue to operate, it will be no downtime. This is one of the examples of concrete scenario. Just give me 1 second to, yeah. Now, based on this, how should we deal? What kind of decision we can make? Next step is tactics. So tactics for availability, what they can be. Tactics for availability are categorized into detect the fault, recover from the fault, or prevent the fault. This is the different tactics that you as a designer can add into your system. What will be the action in case of this or other scenarios are happened? How you can resolve them? Let's take a look at them and try to understand. For example, detect the fault. So when we are talking about availability, we generally can divide into detect the fault. It means detect. What it means? At least if the system is not available, we can detect it. There is different approaches. How can we detect? In case if we already have some faults, how can we recover from it to make the system available? And how can we prevent? So detection tactics depend on essentially on detecting signs of life from the various components. There are different of them. For example, one of them is ping echo. What it is? Ping echo, it's nowadays I will say that it's not used quite usually, but maybe you hear about this about the ping from the command line when the admin can ping some IP address and it expect that it will respond you with this ping. Is it successful or not? This approach can be applied even into the design. So ping echo refers to an asynchronous request response message peer exchange between nodes used to determine reachability and some delay through the associated network path. But the echo also determines that the pinged component is alive and responding correctly. So the ping is often sent by a system monitor. Ping echo requires a time threshold to be set. And this time will tell the ping component how long or to wait for the echo before considering the ping components to have failed. I'm talking about timeout. So you can specify the timeout for these tactics. And based on this, you can say that, or you can build your system with inside using this one of the tactics. that will detect the fault that can happen in your system. So it will send request, ping, and wait for some time to response. If the response is echo, as the response will not come back, then you can detect that your system has some issues. The another one is monitor. So a monitor tactic. Monitor is a component that is used to monitor the state of health of various other parts of the system. Processor, processes, memory, and so on. If, for example, in Spring, it maybe some of you hear about the actuator, and there is endpoint health. Also, maybe you hear about the Grafana, which can monitor the health state, or it's just more as a representation part, but at least it indicates some characteristics. Heartbeat. What it is heartbeat strategy? Heartbeat is a fault detection mechanism that employs a periodic message exchange between a system monitor and the process being monitored. To be short, look, a heartbeat is quite similar to ping echo, but the idea is that in a ping echo, you will initiate the request. From your side, you will send the request ping and will expect the response echo. In heartbeat, in reverse order, the resource who will generate the successful response will be from another side. So the big difference between heartbeat and the ping echo is who holds the responsibility for initiating the health check, the monitor or the component itself. Another one is timestamp. This is a tactic is used to detect incorrect sequence of events, primarily in a distributed message passing system. So it means that inside of the message you can use some timing values, or simple sequence numbers can also be used for these purposes to determine is this communication works in a proper way or not. How much time do we have till Zoom will drop us?
2 minutes.
2 minutes. Okay. Maybe let's make a graceful shutdown. So we will stop recording here and continue. Yeah, look, interoperability before. So we'll make a pause here. Next time we will continue with taking a look into different tactics for availability. And after that, it will be another quality attributes like interoperability and so on.